In this video, we will learn about the basics of AWS Glue and its benefits. AWS Glue is a data integration service offered by Amazon Cloud. It makes it very easy to discover, clean, combine data from various sources, and prepare it for machine learning and other advanced analytics. AWS Glue really helps to shorten the time needed to prepare and integrate data for analysis from weeks to a matter of minutes. It is an extract, transform, and load service that helps data engineers to discover as well as to extract data from multiple sources. It helps them transform the data by cleaning, normalizing, and combining it. And finally, enables them in organizing and loading data in a data lake or a data warehouse. AWS provides data scientists both a visual and an API-based capability for data integration. It is very capable of allowing developers to create custom ETL workflows using intuitive visual interfaces. Now let us look at AWS Glue Advantages. One big advantage of using AWS Glue is that it helps automate most of the processes required for data integration. It can crawl data sources and identify formats as well as automatically suggest schemes needed to store data in a warehouse. AWS Glue also generates code that is needed to transform data and load it to the right location. Post this process, AWS Glue then creates a catalog of metadata, which is essentially a repository for the datasets containing details about type, location, and attributes. Now let us discuss AWS Glue core features. One core feature of AWS Glue is that it can also be set by certain event-based triggers, and various ETL jobs can be started and run in parallel. AWS Glue also has fault tolerance built into it, and jobs that fail to run are retrievable, as well as event logs in Glue can be debugged. Lastly, it is a serverless service. Users do not need any infrastructure for running data integration tasks, and they only pay for resources that are being used while running Glue. Moreover, AWS Glue can be used to combine and replicate data from various sources, such as Amazon DynamoDB and Amazon Aurora, using SQL. In this video, we will learn about AWS ETL use cases and pipelines. There are a few different kinds of AWS ETL pipelines that can be created by data engineers. The first one would be event-based ETL pipeline that is triggered whenever any new data is loaded on Amazon S3 or any other data store. Users can use the AWS Lambda function to trigger one or more than one AWS Glue ETL jobs. Glue can be used to catalog metadata as well as to transform and load it to a target data store like Amazon S3 or Amazon Redshift. AWS Glue can also be used to create a central unified catalog that crawls and discovers data across different data stores automatically, and creates a metadata catalog that is available for search by different services on the AWS platform for data analytics. All of this can happen without actually moving the data. Now, let us look at some of the core features of AWS Glue. AWS Glue has a feature called AWS Glue Studio, which enables users to use a visual drag and drop editor. A visual drag and drop editor is used to manage the ETL pipelines without actually having to write any code. The Glue Studio can move data from any data store and then create complex ETL pipelines using a visual interface to transform and load the data in data lakes and in data warehouses for analytics. Using the drag and drop editor, the Glue Studio enables users to automatically generate the requisite ETL code that can be deployed as intended. The code is generated in Python or Scala and is designed for Apache Spark. Lastly, AWS Glue Studio allows us to send data to other AWS services for deriving insights on the data. Another of AWS Glue feature is called the AWS Data Brew, which is a visual data preparation tool that can evaluate the quality of data that is extracted from data lake or data warehouse. And by using the visual interactive interface, the data can be transformed without having to write any actual code. This feature enables users to clean and normalize the data up to 80% faster. The transformations can be saved and further applied to new data automatically as it is extracted in the system. Hi, In this video, we will be setting up a basic ETL job using Amazon Glue. First, let us look at the data that we have in Amazon S3. In Amazon S3, we've already created a bucket that stores daily incoming data from Forex markets. It is stored under Daily OHLCV AWS ML Course bucket. Do note that the access of this bucket is set up so that our Amazon Glue can access this bucket. Now, let us view what's inside this bucket. As we can see, inside the bucket, there is a folder called incoming data. Inside this folder, there is one .csv file that is updated once every day. Now, we will set up a basic ETL job using Amazon Glue, wherein it will read the .csv file, transform the data, and save it back into our S3 as processed data. For that, let's log into Amazon Glue. To successfully set up this ETL job, we would first need to set up our crawler. A crawler would connect to our data store, which in our case is S3. It will then determine the schema of our data and create a metadata table in our AWS Glue data catalog. Now let's proceed with creating a crawler. First, we need to name our crawler. Let's name it as read OHLCV metadata. To proceed, we can click on next. Now we need to choose the source type for our crawler. In our case, this is the data stores because we're using S3. Proceeding on with the default options, we can click on next. Herein, we need to specify the path of a data store. For this, we can choose the folder option and specify the path. To proceed, we can click on next. Now, AWS Glue is asking whether we want to add another data store. In case we were proceeding with more than one data store, we would click on yes and proceed to next step, wherein we would be asked to specify the path of the new data store. In our case, we will let the default option be and click on next to proceed to the next step. As Amazon is specific about creating access roles, let's name our role as Access S3. Herein, we can choose the frequency schedule for our crawler. We can run it on daily basis or on hourly basis. For now, let's run this on demand and click on next. As a next step, we need to configure a virtual database wherein the crawler's output would be stored. For this, we can add a new database and call it OHLCV metadata. To finish this step, we can click on next and proceed to the next step. Herein, we can review the configurations that we have just set up, and if we are satisfied, we can click on finish. As in one of the earlier configuration steps, we chose to run our crawler on demand. We will have to manually run our crawler. To manually run our crawler, we need to follow this process on screen. We need to select our crawler name and click on Run Crawler. Now, as it shows in the notification that our crawler is still running. At the end of this run, a new database table would be created in the data catalog. Let's check that out. As we can see, there are two databases in our data catalog, but the one that we are interested is the first one, which is called OHLCV metadata. Let's see inside what the contents are. We can look at the tables in OHLCV metadata. As we can see, there's one table called incoming data that is picked up from our S3 data source, and the metadata is stored here. Let's go inside this table to look at the contents. This page shows the metadata of the incoming data that our crawler just picked up and the data types of our data columns. We have successfully completed the first step of creating a crawler and storing the metadata in a virtual database. Now we can go on to create an ETL job. For that, we can go to Jobs under ETL section. Now we have reached a page where we can create an ETL job. An ETL job can be initiated by triggers which can be scheduled or can be driven by events. To create our first ETL job, let's click on Add Job button. Herein, we are required to configure the job properties. First step is to name our job. Let's name this job Process OHLCV Data. As a next step, we need to choose the IAM role for this job. Let's pick up an IAM role that we picked up earlier in our configuration step. Next step is to choose the engine on which our job will be run. Spark is a good engine for big data analytics. Let's keep it as default. Next, the Glue version is Spark 2.4 running with Python 3. Essentially, we're running PySpark. We can choose the default options. A script will be generated by AWS Glue. To proceed to the next step, we can click on Next. Herein, we need to pick up the incoming data source. As we've already created an incoming data source, let's click that and proceed to Next. In the next step, we have to choose a transform type. Herein, we just have one option of change schema. Let's proceed with that. Now we need to choose a data target that we have as incoming data already. Let's select that and click on Next. Now this is the output schema definition as read by Amazon. As we can see, the source columns are mapped with target columns. If we choose, we can add or clear columns as required. Since we don't want to make any such changes, we can go on and save job and edit the script. As a result, AWS has created a default script. At this stage, we can write our own code and make a more complex transformation. Herein, we could aggregate open, high, low, close data to something else. To keep things simple, we can just click on Run Job. Now our ETL job is running. Now, once this job is run, we should see an output in our S3 console. Let's wait for the job to run. Now that our job is run, we can proceed to our S3 console to check out the output. As we can see, there's an output file added by Amazon with a default complex name. This is added in our Amazon S3 bucket in incoming data folder. We could choose to select the file and download it on our system. On opening this downloaded file, we will see the transformed content from our USD-CAD daily.csv file. We have opened the file and we can see the transformed content again in .csv format. You can use this demonstration video as a starting point to help you create your first ETL job. After you've successfully run your first ETL job, I would recommend that you create more complex jobs on Amazon Glue to understand its true potential. In this video, we will understand what is streaming data, what are its benefits, and see some real-world examples. Streaming data is data that is continuously generated by various sources that send small sizes of data continuously and simultaneously to a data repository. Streaming data needs to be processed sequentially per record or by clubbed time periods. Streaming data is used for assessing correlations between incoming data, getting insights into various business activities as well as customer behaviors. Examples of streaming data could include trading activity information, data logs from customer activities online, e-commerce sales, clicks on social media networks, or from data logging devices that are deployed physically. Streaming data is helpful in making business intelligence decisions promptly by continuously analyzing streams of incoming data in real time or near real time. Now, let us look at some of the application and benefits of streaming data. Data processing has moved from a structured and legacy infrastructure that had only a few sources that were generating data. Nowadays, data is generated by a large gamut of sources, and it is difficult to enforce a common data structure or to control the frequency or volume of data. With dynamic data being continuously generated by these sources, it has become imperative for companies to process, analyze, and respond promptly. Initial application of stream data processing are limited to collecting basic information about the data that is incoming. Further, data stream processing applications have evolved to perform basic analysis of the data in real time and creating simple reports along with simple tracking of any thresholds that are triggered. Lastly, streaming data capabilities have now evolved considerably where sophisticated machine learning algorithms can be applied in real time to incoming streams of data, and valuable insights that are really helpful in business intelligence can be gained from it. In this video, we will understand the differences in the traditional batch processing of data and the evolving stream processing of data. We will also discuss various challenges faced in both types of processing of data. There are two different kinds of processing for data, namely batch processing and stream processing. First, let us discuss batch processing of data. Batch processing is computing queries over a collection of different sets of data and deriving results by analyzing large quantities of data. Batch processing is better suited for larger data sets, and as batch processing is comprised of complex data analytics, there are latencies in it that last from minutes to a few hours. And batch processing is used for advanced analytics. On the other hand, stream processing is a form of data ingestion that deals with a sequence of data with simple analysis performed on every data record that is incoming into the dataset in real time. Therefore, stream processing processes individual records. Stream processing is used for computing simple metrics and responses on individual records or small batches of data. Therefore, the latency in it is really low and the performance is almost real time. However, in the real world, most businesses use both batch processing and stream processing approaches to analyze data, whereby basic insights are drawn from incoming data using stream processing techniques and tools, and then the data is transformed and loaded onto a database for in-depth batch processing and analytics. In this video, we will learn what is Amazon Kinesis and its features. Amazon Kinesis is a service offered by AWS that enables users to collect, process, and analyze streaming data in real time so that insights can be generated instantly and intended actions can be implemented very promptly based on the new information that is collected. Amazon Kinesis allows data ingestion in real time comprising of various forms of streaming data, including video, audio, online clicks, data coming from connected devices, application logs, and other sources from machine learning, as well as basic data analytics. As it is a real-time service, it enables businesses to respond immediately based on the information that is being streamed, rather than waiting for all the data to be collected before analytics can be started. It has cut down the time needed to derive insights from new information from hours to a few seconds or few minutes. It is scalable to manage large volumes of streaming data from multiple sources without significant delays. In this video, we will learn about various capabilities and uses of Amazon Kinesis. First, let us look at the capabilities of Amazon Kinesis. Amazon Kinesis has the capability to analyze both video, audio, and data streams in real time. With video streams capability, Amazon Kinesis makes it easy for users to connect video devices and collect the streaming video data on AWS for further analytics, machine learning, and processing. Amazon Kinesis can also capture real-time streaming data that is coming from thousands of sources durably. Another capability of Amazon Kinesis is to allow users to Firehose, capture, transform, and load streams directly to AWS data stores for real-time analytics. Users can analyze incoming data streams using SQL or Apache Flink, which is an open source framework and engine for processing of data streams, and users can do so without the need for learning specific programming frameworks. Now let us look at some of the use cases of Amazon Kinesis. Kinesis is very useful in the real world for analyzing video streams coming from camera devices that are located in homes, offices, or in factories for monitoring, face detection, and other machine learning applications. Kinesis allows companies to record public data in real time and update their online databases such as Xylo that uses public data to update home values in real time, thereby making sure that its users get the most up-to-date estimates when they're browsing the Xylo website. Sonos uses Amazon Kinesis to ingest billions of events from its wireless devices and analyze it to deliver a better audio and listening experience to its customers. In this video, we will learn how video streams work in Amazon Kinesis. Amazon Kinesis video streaming capability enables users to connect camera devices directly to AWS. It has the capability to ingest, securely store, and encrypt incoming video streams that can be used for real-time playback as well as for machine learning and analytical applications. Kinesis can be scaled to ingest video streaming data from millions of devices such as smartphones, security cameras, dash cams, as well as drones and satellites. It enables users to build applications with real-time computer vision and machine learning. It protects data by automatically encrypting it and supports a two-way real-time video streaming interaction between connected devices, thus enabling video chats and peer-to-peer sharing with almost zero latency. All the data that is stored on Amazon S3 using Amazon Kinesis video streams, it is searchable based on incoming devices and the generated timestamps. A real-world application of Amazon Kinesis video streams would be an interaction that a user has with the person at their doorbell remotely from their smartphone. The camera-enabled doorbell is used to capture and stream both video and audio live stream to Amazon Kinesis video streams that ingests, stores, and indexes the data, which then sends it to an application that has the capability of playing that stream on a smartphone or a browser. This is then fed to the user to communicate with the person at the door, all with near zero latency and in real time. In this video, we will learn how data streams work in Amazon Kinesis. Amazon Kinesis Data Stream is a streaming service that enables users to continuously capture very large amounts of data coming in from the thousands of sources such as websites, IT logs, social media interactions, etc. The data that is collected from a multitude of such devices is available in real time for analytics that are then used to create visual dashboards, quickly identify any anomalies, and to take business intelligence decisions with minimal lag. A real-world example of Amazon Kinesis data stream would be the data that is collected by player interactions on a gaming platform. This data is continuously fed to the gaming platform, which in turn analyzes it and dynamically reacts to it, thereby providing the players a really engaging experience based on their actions and interactions in real time. In this video, we will learn what is Data Firehose and how it functions with Amazon Kinesis. Amazon Kinesis Data Firehose is a capability that enables users to prepare and load real-time data streams to a target data stores and other analytical services. It can transform and deliver streaming data to AWS services such as S3, Redshift, Elasticsearch, and other service providers such as MongoDB or Datadog. Firehose has the capability to scale automatically based on the amount of data that is flowing through and has capabilities to encrypt, transform, and compress the data streams to optimize storage. It is a very simple service to use through the AWS Management Console and has a serverless data transformation capability that helps users to convert raw streaming data into formats that are required by the receiving data stores without having to build custom pipelines. Amazon Kinesis Data Firehose works in near real-time speed and can continuously load data streams to destination databases automatically while scaling as needed. One key difference between Firehose and Kinesis streams is that Firehose can be scaled to handle gigabytes of streaming data per second. And it has capabilities for batch processing, encrypting, and compression of data. As Firehose scales to meet demand, it is different from Kinesis streams in which the user has to manually provision enough capacity to meet anticipated requirements. In this video, we will learn how Amazon Kinesis Data Analytics can send processed data to various tools for real-time alerts and actions. Amazon Kinesis Data Analytics is a service that enables users to analyze and transform streaming data in real time and thereby get actionable insights from it with Apache Flink. It enables users to easily integrate Apache Flink with other AWS services. As with Kinesis Firehose, Kinesis Data Analytics also scales automatically to handle the volumes of incoming data and is a serverless application, which makes it useful for optimizing cost as there is no infrastructure to manage for users. Amazon Kinesis Data Analytics has the capability to filter, aggregate, and transform incoming streaming data for advanced analytics with extremely low latencies. thereby allowing users to analyze streaming data and create actionable insights in real time. One of the real-world applications of Kinesis data analytics is Gnosi, that processes over 500,000 records per minute for creating personalized and curated news feed for its end users. Hi, in this video we will access a real-time data feed and store it into a data store using Kinesis data stream and Kinesis Firehose. Let's proceed to launch AWS Kinesis console. For the purpose of this video, we will use Kinesis data streams to collect real-time Bitcoin price data in USD. Then, we will use Kinesis data firehose to process and deliver this data to our data store S3. However, instead of S3, we could use any other data store such as MongoDB or SQL, or we could even use a data analytical tool that collects real-time data. Before we set up Kinesis data stream, let us look at how our real-time data stream looks like. What we see as an output of this code is a real-time price data of Bitcoin with USD that is updating every 2 seconds. First, we will use this real-time price data without connecting to Kinesis data stream. Then, once we have set up and integrated Kinesis data stream, Kinesis Firehose, and our data source S3, then we will stop this service and run the second service where we will send the data to Kinesis data stream. Now let's begin our journey to create a Kinesis data stream. In order to create a data stream, first we need to set up the configurations for our data stream. As a first step, we need to set up a data stream name. Let's call this price data stream. As a next step, we need to determine our data stream capacity and input the number of open shards. For our test case, let's give the number of open shards equal to 1, wherein each shard would be able to ingest up to 1000 records per second. Since for our test case we are only running 1 record per 2 seconds, so we are good with 1 shard. However, if we were running real-time prices, including multiple assets, then we would scale up to as many number of shards as would be required. For now, let us proceed to the next step. Now our price data stream is getting created. Before creating our delivery stream, let us go inside and look at our data stream. Now it seems our price data stream is active. Now we can go ahead and create our delivery stream. Again, we need to set up the configurations for our delivery stream. Let's name this price data to S3. Next, we need to choose a source for our delivery stream. Our source is the Kinesis data stream that we just created in the previous step. So let's go ahead and connect this delivery stream to our data stream. Here, we will choose Kinesis data stream as our option. Then we will choose the price data stream. Then we are good to go on to the next step. Here, we have an option to transform our source records with AWS Lambda. AWS Lambda could allow us to filter some records out of the real data stream. For instance, we could use AWS Lambda function to filter and only store those records where the bid-ask spread is greater than over a certain range. For now, let us proceed without any data transformation. Keeping other values as default as well, let's proceed on to the next step. As a next step, we need to choose a destination for our delivery stream. This could be Amazon S3 or Redshift or Elasticsearch, or it could be an API endpoint if you're creating your own application, or it could be a third-party service provider such as a data analytical tool. For our case, we're using Amazon S3. So let us choose a bucket. We will be using the same bucket that we created in the AWS Glue demo. Proceeding to the next step. Here we can configure some more settings. For now, let us keep this as default. However, we can choose an existing IAM role that we created earlier. This screen allows us to review and accept the configuration once more. Since everything looks good, we can create our delivery stream. Now that we have set up our data stream and data firehose and integrated the data firehose to our S3 bucket, we should be able to retrieve real-time data and proceed to store it in our S3 bucket. So let's stop running of this code and run the second version of the code. Now we will retrieve real-time price data and send it to Kinesis data stream, which will send it to Kinesis data host, which will send it to our S3 bucket. Now we should be able to see this data in our S3 bucket. So let's log on to our S3 console and view this data. Now let's go inside our selected bucket. Here we see a new folder. Now we see these latest records being uploaded on our S3 bucket. Let's download one of these. Now if you open the downloaded file, we see records with bid and ask being stored of the most recent timestamp. Moreover, if we go back to our Amazon Kinesis console, we see one data stream and one data Firehose stream are activated. With this, we end this introduction to Amazon Kinesis. Now we come to an end of data movement in AWS course. In this course, we learned about AWS Glue and data processing. We learned about AWS Kinesis and data streaming. Also, we saw practical tutorials on setting up your first AWS Glue job and setting up your first AWS Kinesis job. In the next course, we'll learn about data pipelines and workflows.